Alright, here in this problem, let's get it right in there, we're given a function. F of x equals 50,000 times 0.975 to the x power. So this is kind of going to be important to us. We're going to be using this function here. This function just gives us the, as you can imagine, as you get deeper and deeper and deeper in the ocean, the light intensity, or like the brightness, gets smaller and smaller and smaller because the sun has to go through more water, right? So down at the bottom of the ocean, it's darker than it is near the surface. This function lets us know what the light intensity is at different heights of the ocean. So here it tells us that in the waters of, Tobermory, Ontario, Canada, lies a sunken ship called the Sweepstakes, and the intensity of light at the shallowest point of the wreckage is about, and this is going to be the key number here we're going to be using to plug in, 42,849, and it's calling this the intensity of light. Lumens per meter squared. Okay. At what depth, so our variable, or the x portion, is going to be here. At what depth in meters is the ship sunk? So what we're trying to find out is what height it's at. X represents the depth in meters. So we're actually going to be solving for x, and f of x represents the intensity of light. So that means we're going to plug this 42,849 in for the f of x, which is a little different than usual. So that's why I wanted to highlight that. We're used to just plugging things in for the x, not for f of x. Okay, well, if we do that then, this number here is going to come in for f of x. So we'll get an equation that looks like this. 42,849 is equal to 50,000 times 0.975, and we don't have anything to put in for x. That's what we're trying to solve for, so to the x power. Alright, now the way that we solve for x here is first I'm going to divide both sides by this 50,000 to clear it out of the way. So divide by 50,000 on the right side and on the left side. And I'm going to pause. And okay, when I put this in a calculator, I got that 0.85698 is equal to this fraction. And then, of course, 50,000 divided by 50,000 just cancels, and we're left with is equal to 0.975 to the x power. Now, what do we do to get this x down? What I like to do is just take the logarithm of both sides. And I always use the natural logarithm ln because it's usually listed in a calculator. So I will go ln of 0.85698 is equal to, remember, whatever we do to one side, we have to do to the other side. So it's equal to the ln of 0.975 to the x. The cool rule about taking logarithms is that the exponent is not an exponent anymore. It gets to be brought down in front is multiplication. And so you can think of the same way that division is the opposite of multiplication, or addition is the opposite of subtraction. Logarithms are the opposite of exponents, and so they'll undo the exponent. So here we'll get that the ln of 0.85698, that'll just be some number we'll have to put in a calculator, is equal to x, we get to bring it down as multiplication now, times the ln of 0.975. Okay, pardon me while I put these logarithms into a calculator. Okay, I got a couple decimals for us. This logarithm turns into negative 0.154, and this logarithm, the one that's being multiplied by x, turns into negative 0.0253. So our last step is, of course, to divide by this, so we can get x all by itself. Negative 0.0253, and divide this side by the same, negative 0.0253. And when we put that into a calculator, we get that x is equal to 6.083, which tells us that the ship sunk at that many meters under the water. Is that deep? To put meters into feet, we'd have to multiply it by 3, so that would only be about 20 feet under the water. Not too deep at all. Alright, thanks.